Hello guys. So in this video, I would like to show you how can we relate the value of G, and capital G. So this G, the small g is the variables that we call as gravitational acceleration. Acceleration. So what is gravitational acceleration? Gravitational acceleration. So what is gravitational acceleration? It is actually acceleration. Okay, it is actually acceleration which is caused by due to gravity. Gravity. So it is actually the value of acceleration. So the unit should be meter per second square, ms minus 2, since it is an acceleration. G, as what we had learned in our previous lesson, so capital G here is the gravitational constants. Okay, here we have the word constant. That means the value is always the same, no matter where we are, okay, or when they are. So it should be equal, which is equal to 6 point, I'm not remember the number, okay, 6.67, okay. 6.67 times 10 to power of minus 11, okay, minus 11. So what is the unit for this gravitational constant? So the unit is okay, the unit is nm square kg square. So nm square kg square. Okay, nm, we can write it as Newton meter square over kg square. Okay, so today we look how can we relate, okay, what is the relationship between G and G. So for that purpose, okay, first let me draw you a simple diagram to show one situation where, okay, where we have, let's say this is our earth, okay, our lovely earth, and this is the center. So the mass, let's say the mass for our earth is equals to m. Of course we know the value, but for this in this chapter I will not use the amount, since I don't want to substitute the big number there. So I just use m. And then let's say we have an object placed on the surface of the earth, and the mass of this object is equals to m. Okay, so what is the state of motion when any object is placed on the surface of earth? Okay, what is the state of motion? Okay, what we had learned before, okay, based on the Newton's second law, okay, any object which is placed near to the surface of earth will move, or will have the value of acceleration which is equals to g, right? Any object near to the surface of the earth will move with acceleration equals to g towards the center of the earth. Okay, so that means our object here is accelerating. Okay, so based on the Newton's second law, any object which is accelerating, or any object which is the value of a is not equals to 0, so there must be a force acting on this object. So let's make this is our object outside the diagram. Okay, take it outside. So it is accelerating downward. So that's mean there must be a force acting on this object. So based on Newton's second law, since it has mass and it is accelerating, so the force acting on the object is equals to F. Okay, and then so F here is the force that make this object accelerate towards the center of Earth. M here is the mass of the object, and A here is the value of acceleration of the object. And as what we had learned before, the value of acceleration for any object placed in the area of the surface of Earth is equals to G. So we can substitute here F equals to M equals G. Okay, so for this purpose, let's just put there the F here is the force based on second law. Okay, the force based on second law. Okay, next for the same situation. Okay, same situation, but we try to investigate in terms of Newton's law of universal gravitation, which is F equals to gm1 gm2 over r squared. Since we have two objects, okay, two objects, and based on Newton's law of gravitation, universal law of gravitation, when we have two objects, there will be interaction between these two objects, where they will be attracted with forces, which what we call as gravitational force. So here, just put it as gravitational force. Okay, so the value of gravitational force here is equals to G. M1 is the mass for the first object. So just let's make our Earth as our first object. So M, and then M2 is the mass for the second object. So second object, the mass is equals to M divided by R. So R here is the distance between the center of first object and the center of the second object. So the center here, since the second object, the smaller object here, is placed on the surface of Earth. So for that reason, we just assume that, okay, the distance between the first object and second object is equals to the radius. Okay, why don't we take the center of the object? Okay, why don't we take the center of the object? This is the radius, okay, and this is the radius of the second object. So should V equals R plus R big tambah or plus R small. Okay, so to make it simpler, okay, we just assume that the radius of the second object is negligible, since it is very small compared to the radius of Earth. So any object, maybe it is not on the surface of Earth, maybe just near to the surface of Earth, still we take the distance equals to the radius of Earth. So just use the radius of Earth, okay, RE. So this is the force, or the gravitation force, gravitational force. Okay, now let's look back into our diagram here. Okay, so this force, okay, if we try to look carefully into this object, okay, there is no other reason or there is no other cause that will make this object will have this kind of force, except the only one, which is the gravity. So that's mean the F that we get in the second law is equivalent to the F, or to the force caused by the gravity, or the gravitational force. So we can equate these two equations, and then just substitute the term that we have here. Second law is equals to mg, while the Newton's universal law we have G M over R E. Okay, this is for Earth, and of course M here is M Earth, and G here is G Earth. Okay, and then the second object which is the mass is equal to M, we can cancel out. So what we get here is GE. Okay, GE. Okay, just put here GE. Since we are dealing the object on Earth, okay, GE here. So and then ME, mass of Earth, okay, equals to GME over RE. So this is the relationship between G, gravitational acceleration, with G, gravitational constant. Okay, so what we have here, you can see there, we can also relate the value of gravitational acceleration on the surface of any object G with the not only the gravitational constant but also with the mass and together with the radius. What does mean? Okay, so that's mean if we want to find the value of gravitational acceleration on any other planet, stars, and any objects, okay, it is sufficient if we just have the value of mass itself and its radius. So this is the gravitational of Earth, mass of Earth, radius of Earth. What if the scientists want to find the gravitational acceleration on Moon? Of course, they need G, which is equal, or the value is always equal. And they need the value of mass of the Moon itself, and also the radius of the Moon. Okay, so hopefully you can understand this concept. Okay, we can get the value of gravitational acceleration by just only using the mass, radius, and gravitational constant. Okay, so maybe after this we look into a few example to make us understand the concept even better. Okay, so that's all for this session.